Imagine a structure subjected to several forces acting in different directions. Instead of analyzing each force separately, what if we could replace all of them with a single equivalent force? In this lecture, you will learn how engineers determine that single force known as the resultant of coplanar concurrent forces. You will also see the benefit of the resultant, why we are calculating this resultant and its direction. So welcome to Structural Engineering Online. In this video lecture, we will learn how to determine the resultant of a system of coplanar concurrent forces. This is one of the most fundamental concepts in engineering mechanics and forms the basis for analyzing trusses, frames, and many structural systems. By the end of this lecture, you will be able to calculate both the magnitude and direction of the resultant force using simple mathematical procedures. Now let's get started. First, let us understand what is a coplanar and concurrent force. Coplanar forces are the forces whose lines of action lie in the same plane, and concurrent forces are the forces whose line of action pass through a common point. As you can see in this figure, all these forces which are given here, they are passing through one common point and they are in the same plane, that is the plane of the paper which is here. Okay, so this way we can define our coplanar and concurrent forces. When several coplanar concurrent forces act on a body, they can be replaced by a single force called the resultant. This resultant produces the same external effect as the entire force system. So you will see the benefit of calculating this resultant. Instead of taking the moment of all these forces, we can just take the moment of the resultant. That will be the benefit which you will see in many problems we will be solving in different other examples also. So now let us come to this calculation procedure. So to determine the resultant, we resolve each force into its horizontal and vertical components, and we will be following these steps. You can see here that these are the steps. So first step, if you see that we resolve all forces into x component and y component. Here you can understand how to calculate the component of a force in any direction. If I have a force here which is given as F, and this force has an angle of theta with some direction, so its component in this direction will be F cos theta, and the component of this force in a direction which is perpendicular to this, suppose this is your x-axis and this is y-axis, so the component in y direction which is at 90 degree with x-axis, its component will be F sin theta. This is the concept that which you have already studied in your statics or engineering mechanics class. So we will be applying all these steps. So please don't miss any of the steps here and watch the video till the end, so you will understand all the steps very nicely. So first step is resolve all forces into x components and y components, as I have told you now, that in terms of these F cos theta and F sin theta, where theta is the angle with x-axis, and the direction of the components will also be similar to the direction of the force. If the force is outward, means it is coming out of the point, then the components will also be coming out of the point. And if the force is going like this, if this is the force that is going towards the joint, then its components will also be going towards the joint. So arrow will be towards the joint. That will be the direction of the components. Okay. So we resolve all the forces into x components and y components in this way. And then we calculate the algebraic sum of all horizontal forces, that is sigma Fx, which equals to sum of all the x components. Then we calculate the algebraic sum of all the vertical components, that is sigma Fy, that is equal to the sum of all y components, means the forces in y direction. Then next step, what we have to do? Determine the magnitude of the resultant force using the Pythagorean theorem, which you can say that now you have resolved all the forces in just x and y direction. So here you say there is sigma Fx and there is sigma Fy. So we can easily calculate the resultant using this Pythagorean theorem. This will be your R, as you have seen in our previous lecture where we calculated the resultant of two coplanar concurrent forces by using parallelogram law. Okay, here these two forces sigma Fx and sigma Fy will be at 90 degree, and it will be very easy that you can calculate the value of R as square root of sigma Fx square plus sigma Fy square. Okay, so this is that way that you can calculate the value of R as square root of sigma Fx square plus sigma Fy square, and then you can also calculate the direction of this resultant with respect to the x-axis. Okay, now we apply all these concepts to our actual problem which is given here in this question. So we have now 4 forces, and these forces are coplanar and concurrent, and the angle of these forces as well as the magnitude is given. So we come to find their components, as it will be our first step. So we come here and see these components. Now if you look at force F1, which is 100 Newton, this force is making an angle of 30 degree with y-axis. Okay, you can easily calculate the angle with x-axis, and that will be equal to 60 degree. So once you know the angle of this 100 Newton force with x-axis, you can find its component in x direction and y direction very easily, and you can say that F1x will be just equal to 100 cos 60, right? We take the cosine of the angle which it makes with x-axis, and that is 100 cos 60, and in y direction F1y will be 100 sin 60. So we have got the components of 100 Newton force, and the direction of these components also deciding outward from the point. This is your point where these forces are acting. Then we come to F2. Now look at the direction of F2. F2 is having the arrow which is going towards the point, right? So in that case, its components will also be pointing towards that. So the direction of the components decided. Now look at the angle which this force makes with your x-axis. It is 45 degree. So we can easily say that its component F2x will be 150 cos 45 degree, and its y component will be 150 sin 45 degree, right? Now we come to the third force F3, which is 90 Newton force, and this force is acting towards the point. So the components of this force will also be pointing towards that common point at which all the forces are meeting. So we can say that this F3 will have its x component as 90 into cos 20, and y component will be 90 sin 20. So we can write here these components. So 90 cos 20, and in the positive x direction, and the y component will be also pointing in the upward direction, that is positive y direction. So it is 90 sin 20. So this way we have got the components of this F3 also. Now we come to the fourth force, that is F force of 70 Newton, but this force is coming out of the point. So the components of this force in x and y direction will also be coming out of that point. Now you can see here the direction of this force. Here in x component, it is pointing in the positive x direction, and the direction of its component in y direction will be pointing in the downward direction of y, that means it is minus y or negative y. Now another thing is to find the angle. Angle is not directly given here, it is given in the form of this triangle 3, 4, 5. So ratio of the sides are given. So from this we can easily calculate this angle theta, which is same as this angle because these two are parallel sides. So from this triangle we can easily calculate the values of sine theta and cos theta. If this is 3, this is 4, this is 5, and here you have theta. So we can calculate the value of cos theta and sine theta. You very well know that cos theta is equal to base upon hypotenuse. So base in this case, if we take this angle theta, so base will be 3 and hypotenuse 5. Similarly, sine theta is perpendicular upon hypotenuse. Perpendicular in this case will be 4 and hypotenuse 5. So we have got the values of this sine theta and cos theta, which we can use here to write the values of these components of 70 Newton force. So F4x, that means the component of F force in x direction will be F4 multiplied by cos theta, and the value of cos theta is 3 by 5. So we can say that F4, which is 70, so it will be 70 into cos theta, which is 3 by 5, and the y component will be 70 sine theta, and sine theta is 4 by 5. So F4y will be equal to 70 into 4 by 5. So this way we have got the components of all the forces which are acting at this common point. Now we go to the next step and we take the algebraic sum of all the forces in x direction and y direction, that is sigma fx. First we will calculate and then we will calculate sigma fy. So sigma fx, which is algebraic sum of all the forces in x direction. So we look at the x components only now. So x component f1x, f2x, f3x, f4x. So we will write the values of these with the proper direction. If you see here, f1x is also pointing in the positive direction of x, f2x is also positive, f3x is also positive, and f4x is also positive. So all of these x components are in the positive x direction. So we will write these values here. 100 cos 60 for this first force. Then the second F2 component plus 150 cos 45. Then the third force 90 cos 20, that is also positive. So we have here plus 90 cos 20, and the fourth force is 70 into 3 by 5. Now when we calculate these values, simplify. So 100 cos 60 plus 150 cos 45 plus 90 cos 20 plus 70 into 3 by 5 with these proper signs. When we put these values in the calculator, we get this value as plus 282.638 Newton. So this way we have got the value of sigma fx. Now the next step is to find the value of sigma fy, that is algebraic sum of all the forces in y direction. Okay, we come to now sigma F y. So here we have to look at the forces only in y direction. F1y is pointing upward, so it will be with plus sign. F2y is pointing downward, so it will be with minus sign. Then F3y is also pointing upward, it will be with plus sign. F4y is pointing in the downward direction, so it will be with minus sign. So we put here all these with the proper signs. So here we have sigma Fy, that is plus 100 sine 60, then minus 150 sine 45. Then we have this 90 Newton force, its y component is positive, so plus 90 sine 20. Then the third force F4y, which is acting in the downward direction, so it will be with minus sign, so minus 70 into 4 by 5. Okay, so now we take the total, put these values in the calculator. Okay, 100 sine 60 minus 150 sine 45, all these values, so we get this value as minus 44.68. So we have got the values of these sigma fx, sigma fy, which are the components of the forces, and this is the algebraic sum of the forces in x direction and y direction. So sigma fx we can say, and sigma fy can be used to calculate the value of this resultant r in this simple way. So r is equal to sigma fx square plus sigma fy square, and when we substitute the values of sigma fx and sigma fy here we have 282.638 square plus minus 44.68 square, and when we take the square root, this value is 286.15 Newton. So this way we have got the value of the resultant force. So now if we look at this values of sigma fx and sigma fy and look at the directions here, this is your sigma fx, which is in positive direction, and sigma fy is in the negative direction, right? That is minus 44. So how this r will be represented? You can say that the value of this resultant is this much, and here is your r. So this will be the angle that it makes with positive x-axis. Now we can easily calculate this angle alpha, which you can calculate alpha as tan inverse, which is sigma f y divided by sigma f x. So we get this as tan inverse minus 44.68 divided by 282.63. And when we calculate this value, we get this equal to minus 8.97 degree. This minus sign indicates that this angle is negative with reference to positive x-axis. So negative we measure like this. If this is your positive x-axis, so any angle measured in this anti-clockwise direction will be positive angle, and any angle which we measure in the clockwise direction will be taken as negative, minus theta. So this way now we have come to the end of this question, because we have calculated the value of R, which is the resultant magnitude, and also the direction of the resultant force. Okay, so now you have seen that in all these systematic steps we can easily calculate the resultant of these concurrent coplanar forces. So in this lecture, what we have learned? We learned how to determine the resultant of coplanar concurrent forces. That also I explained what is coplanar and concurrent forces by resolving these forces into components, and these components we take in x direction and y direction, and then we combine them mathematically, that is algebraically. We take sigma fx value and sigma fy value. This concept is extremely important in engineering mechanics and structural analysis, where you will be dealing with so many forces acting in different directions. If you find this lecture useful, please like this video, subscribe to our channel Structural Engineering Online, and press the notification bell so you don't miss future lectures.